Hey all, in this video we are going to talk about a subject which is a little bit nostalgic to many of the viewers. So the story is that recently to teach some kids some soldering, I ordered a couple of PCB kits from AliExpress and some from eBay, and it was a simple LED chaser kit. One is in the shape of a heart, another is in the shape of a star, and there are some other variations. So I got the kit, and it came with the microcontroller pre-programmed with some chasing program, and then I asked my son to solder. He tried a couple of solder junctions. He said that it's very easy, and then he left it. So I finished the project and then took a run, and then it was all fine. So when I looked at it, it was not an Arduino or any Atmel AVR based microcontroller, but it came with a microcontroller from one of the prominent microcontroller in the East called STC Micro. So I researched a little bit more. I knew about that company, but yeah, I looked it up and I saw that the one board which has the heart-shaped LED pattern, it came with a microcontroller called STC89 52RC. So it's a classic clone of a microcontroller called Intel 8051. So, and when I looked at it, it seems to be very easy to program. So what I did is, some of the PCBs came up with a programming header, and this particular one didn't. So, but even if it didn't come, it's pretty easy. And this particular board came with a lot of board-like holes, right? So this came with a lot of reusable area in the board. Wherever there is some space, they have put perf holes in it so that we can add. So I just added a 4-pin header. I wired the VCC and ground, which is the red one and the ground, and then I also added the RX and TX. So that's all you need to program one of these chips. So it is P3.0 and P3.1. You just wire it and then use any normal USB to serial controller. It is $2 USB to serial, and that's all you can program. So it's very pleasant to watch these effects, because what they did is it's a very simple microcontroller with 4 8-bit ports, I think P0, P1, P2, P3, all 8-bit, and so they have altogether 32 LEDs, and each wired to these ports, right? So, but that only gives you one channel for each LED, but so they have supplied with all this board with 32, or I think they gave 40 plus around 35 or 40 LEDs, which are self color changing LEDs. So this used to be a premium. I think around 10 years back it came, and then now it's available very, very cheap, right? So what this does is, I think each of these LEDs has got at least a 4-bit microcontroller, which has got a ROM pre-programmed with the color changing effects, right? I think it's using PWM to 3-channel PWM and 4-bit microcontroller to with the pre-programmed ROM. It's not even the size of it's not even the size of the diameter of a safety pin, or something like a tip of a pen, or it's not even that small. These microcontrollers are, so they managed to put three semiconductors for red, green, and blue, and then that controller which does also the voltage regulation. So you can power even these LEDs with 5 volt, because it's not directly powered. It's first going through the chip, and the chip regulates and also put the effects into these 3 LED chips. So they provided with this, so it just starts with some pattern, and then it's continuously cycling. So even you can control the color if you programmatically, if your program is tight enough to tolerate you start the LED and you stop at the right time to have that effect. I am not sure if you can start the LED with low voltage and then wait till some time and then boost the voltage so that color will be displayed. I am not sure if that is possible. I think that should be possible. So actually this is a 33 core. One is the main 8051 core, and then each LED has got its own core. So that's why I called it. For $4 you get the full development board with 32 cores which are not programmable, and then 1 core which you can program, right? So yeah, so it's a lot of fun for just $4. So because we are talking about nostalgia, let me remind you what came up to this, right? So in 1970s, I think some calculator company or somebody contacted Intel to design a 4-bit microcontroller, and so Intel started with 4004. It's the first time that they integrated the one full computing aspect, right? Everything ALU and instruction controllable full system in a chip, and then they slightly changed the design to make Intel 4040, and then someone else designed a chip design called 8008, I think CTC or some company, and made Intel to manufacture it. And then I think someone else again reiterated to make 8080. I think it's a little bit more integrated. I don't fully remember the variations between these two, but it's a 8-bit microcontroller. And then that 8-bit microcontroller, the 8080, needed 12 volt, 8 volt, 5 volt, 3 or 4 voltages to work. And then Intel, so what has happened is that when at the time of 8080, another company called Silog, they recreated the same 8080. 8080 is not really an Intel design, it's somebody else who wanted to design it. Some company which manufactures something, I forgot I think it's a building machine or something, I don't know. So Z80 also created the full instruction compatible version of 8080 called Z80, but that needs only 5 volt power supply. So that made it a lot more appealing than 8080, and all the market went with it: home computers, gadgets, keyboard controller, everything. Z80 used to be used like it used to be ubiquitous at that time, right? Everywhere it is there. And then to compete with Z80, Intel created a processor called 8085. It is nothing but an 8080 which works on 5 volts. There was some more optimization which I can't remember now, but it's all minor. So 8085 was very popular because it is basically the Z80 manufactured by Intel. So 8085, after 8085, Intel moved to 16-bit. It was first it created 8086. Then it created a cut-down version, 40-pin package 8088, where it is 16-bit processor but 12-bit bus or something, some low-cost version. And then Intel 186, then 286, then 32-bit 386, and the 486 Pentium, and the rest is history. But during that time, right, so after 8085, there is a gap to optimize the 8-bit market to produce something which is so cost effective and which can be substituted for wherever this Z80 and all this input peripheral controller or any automation kind of market. So that's when Intel created the 8051. I think the original 8051 came with some RAM and then also with some UV erasable flash in one single chip. So all you need is one crystal, two capacitors, maybe a reset circuitry, I don't remember, the original 8051. That's the only thing you need to run a full program using 8051. So that was a huge success, but nobody really cared about outside the people who manufacture components like 8050. So 8051 used to be the controller to go, right? It used to be the only one microcontroller in the market at one point of time. And then after that there are a lot of clones. So 8051, the IP, Intel was ready to license the IP, so many companies entered the market, Atman, Oton, STC Micro. So minimum 1,000 or more than thousands of companies use this IP. There are many companies optimize the IP itself to be much faster and much more faster, much more smaller die area and everything. And until now, it's manufactured in millions and millions and millions and billions of devices. With each device will have at least 10 or even 100 8051. A laptop will have at least 10 8051 controller running for some peripheral or some power management or whatever running. So this is not going to go down. It will always be used. I don't see an end for devices or applications for this particular controller. And so but it's a niche area. There are not many people right nowadays getting into 8051 programming or learning about 8051. It's history, it's legacy. So I thought I'll use this video to even memorize what I know to help somebody who may be interested. Alright. So earlier when people used to work professionally on this type of controllers, right, whether it be Atman or any other, they used to use either they used to develop in Windows, and they used to develop using either a toolchain from Keel or they use toolchain from IAR. I think Keel was the most prominent at that time during the 90s, I think, early 90s to 2000s. Even now Keel is a very prominent microcontroller toolchain developer, but that's not the real area of interest here, especially for open source enthusiasts like me. So I think at the late 90s or in the early 2000s, there is an open source toolchain called SDCC. It is small device. It stands for Small Device C Compiler. That was developed for many 8-bit microcontrollers like PEEK, STC, STM 8-bit, STM8, 8051, many microcontrollers. The STCC can be targeted, and that is what we are going to use to control it, to write programs to it, and then I'll show you how easy it is to develop, even though it is not Arduino. So the only difference between Arduino and this 8051 and some STM8 and PEEK is that there is the C compiler is pretty capable, the open source C compiler as well as proprietary C compiler, but there is not a lot of traction for C++ compiler for this particular 8-bit microcontroller, unlike the AVR series. So AVR series got a pretty good C++ compiler which triggered development of lot of libraries using the C++ paradigm, like class and inheritance and all those things. Many Arduino libraries are still C based, okay, but there are some libraries which are not C based, and the whole concept of Arduino is C++, even though a lot of development is can be achieved in pure C. So that makes it little bit not friendly for Arduino only developer, people who cannot think anything outside Arduino. But developing C is not that hard if you know any development, right? So only thing is you need to little bit have a learning curve, but after that it's just the code looks exactly the same. There is only conceptual programming difference, not a linguistic programming difference between the C and between the C programming for 8051 and Arduino programming for the AVR. So that's what the development scene looks like. So this particular STC Micro is a very prominent 8051 core based SoC developer. This particular 89C52 is a classic microcontroller, meaning that it doesn't have a lot of modern peripherals built in like I2C, PWM, SPI. This doesn't have. It has just got GPIO or whatever normal ports, right? It has some ADC and then normal input-output ports, nothing else. So if you have to interface with I2C or SPI, you have to use software emulation, right? You have to write the code to emulate an I2C bus using this this big bang GPIO pins. That's how in olden days all these buses were interfaced. So the STC has got many new micros, the STC8 series, which has got all this I2C and SPI and PWM built in. But this particular device do not have it. And also 89C52 series and STC12C series is the classic, it follows the classic 8051. So classic 8051, which has Intel designed, it uses 12 clocks to execute one instruction. So if you give a 12 megahertz clock, it will just execute 1 million instructions per second. So it takes 12 clock, 12. It's a complex instruction set, it's not a risk per instruction one. So this particular thing follows, but STC at that time itself, right? These are one of the early STC clones, 89C5 and 12 series. At that time itself, STC introduced a feature to double the clock. So double the throughput. So what does that mean? You can configure this to run on 6 clock per instruction, right? So if there are the reason why the STC didn't make that as default is if you are using this microcontroller to run a very old developed code which relies tightly on the timing of the clock and etc. So then you can use as it is without the 6 clock, as it is with 12 clock per instruction, and it should be running the 30-year-old code without any issues. That's why STC didn't make the 6 clock instruction as the default in these chips, right? And then there are a lot of modern 8051 clones like 15F, 15W, STC8 from STC Micro itself, and from many different manufacturers which uses 1 clock per cycle. So which are very fast, and it can go up to 48 megahertz with the inbuilt clock generator itself. So it can be very fast for many different applications. So that's about STC Micro and this particular controller. So as I mentioned before, the STC open source toolchain is very efficient and very capable now. And then for flashing this STC Micro, or any STC 8051 based controller, you just need a simple you just need an open source tool like STC Gal, which is a Python based, or STC8 Prog, which is a C based. You can compile it and run it on your Linux machine or Windows machine if you are that illiterate, I would say. I won't advise anything outside Linux machine for any modern development, but yeah, that's up to you. Mac is okay, but why Mac if you have the superpower of Linux within you, right? So that's it. And then to program. So that's the cool thing about STC Micro. STC Micro don't need any special programmer to flash. You just need a serial port. So STC Micro P30, P31, port 3 0-bit and port 3 IO port. Just wire it to RxTX and use a normal $2 USB to serial converter. And power and the VCC and ground. These are the only things you need to flash it. So once you connect it, you can. It's very easy. So what I did is, so I got this controller. So it came up with some effects, which almost look like whatever you see in the table. It's not a ditto, but what I did is I recreated this effects and made it easily workable using STCC, and make it easily workable using PlatformIO using Visual Studio Code or VSCodium. I would advise to use rather than the bloatware VS Code. VSCodium is a open source version of the without any bloatware version of the VS Code, which is the right choice. So if you got one of these boards and want to play with it, all you need to do is just search for STC89 Firmware, either clone or download the zip, and then extract it in some location and open it using Visual Studio Code or VSCodium. So all you need to do once you download is you have to make sure that you go to extensions and install the PlatformIO. So the PlatformIO IDE. If you are using Visual Studio Code, it comes directly in Extension Marketplace. Otherwise, very easy to install. If it is in VSCodium, you just download the VSIX from the Visual Studio PlatformIO repo, PlatformIO website, and then it will download a file called VSIX with the extension VSIX, and click install from VSIX. You can easily install. Once installed, it's just easy. It's just the same. All you need is you open the folder wherever you downloaded, and then click on the build button. It will build. So and flash, you just use upload. So if you have any trouble flashing, just directly use the STC. I have I just messed up with this PlatformIO, and the original PlatformIO is not able to, the PlatformIO that came up with, oh, it is working, okay. Yeah, that's it. So you just have to flash it and you can make any program. So the code is here. We can go through the code. If you have any doubt, you can just give me a message. You can add more effects. You can change the current effect and give me a pull request. I will add it. So it just does what it does is it just do a while infinite loop. First it will set up the ports, and then you can look at the code here somewhere that is set up, and then it will call each effect. It will call 3 times, and each of these effects is called as separate functions. So you just download, and then you can add more. Copy one of the function and change one function, and then add the function in the loop, or just remove the loop and then just add your function, or however you want, right? So that's all it takes to develop, right? So there is one more board that I have, which is the star version. This one came up with the 15W204. It's a 1T, meaning 1 clock per cycle. It is much faster than this one. So I have also added the code for that one. So let me show you. It's called STC89 Bling Star. So that also you can easily, same thing, download the code, open it in Visual Studio Code, and then just click the upload. To just build, you just click the build, you just upload, then you can read about, you can even do this from command line, PIO, run PIO, upload or something. So that easy it is to develop. Using Visual Studio Code is very easy, very clear. So yeah, so this is, you just download the code and run it. So yeah, that's it. For $4 you will get the kit, you get the soldering, you can do the soldering, you can do the programming, you can create your own. So this STC Micro came up with as you can see, it came up with the RxTX and the ground VCC TX RX. So it already came up with a header, so you can just solder this header and connect and start developing. And so it also has the provision to have the barrel jack and the switch, which I didn't use. I just directly connect power. So yeah, this effect is not that great. So I didn't develop. I spent a lot of time in the star one. I just spotted whatever is there in the whatever is there for the this one and do stuff. But you guys can, whoever is having this can enhance it. Give me a pull request, or if I have some time, I'll make that also a little bit more blingy. So yeah, so I also added a reset button. But these are all not needed. You only need the 4 wires to program. Nothing else is needed. Yeah, it's it's nice to even look at it. Your own code running in this very bare basic development board by today's standards. But there is one more thing that I would like to show you. Recently, some guys, I think they are based in China, has started creating a very capable library suite for these STC micros. So they have STC89 library. They have also added support for PlatformIO. So we can easily add this library to our PlatformIO project, and then this has got a lot more peripherals ready to use, right? So they have examples on how to use whether it is GPIO, whether it is timer, whether it is UART. So the send string hello world is that easy, right? So UART send string hello world, just everything else it will do. So do a sysinit and then UART send string. And then you can also make sure that you only compile whatever is needed using the compilation flags. So they have added that also. There is extensive documentation also available from their page. So this is I would like to show some focus on this because this is a lot of great work, and it's very important to make sure that people get acquainted to this 8051 controller and STC89 Micro, especially in the current business scenario where the chip shortage will force developers to go multi-platform, meaning a same application with multiple controllers. We may be forced to do it depending on the availability, and this is one line of controllers which will have a lot more availability and which is a lot capable in line with any other microcontroller like either AVR or PIC or STC8, and it's totally fully open source compatible. So everything flasher, toolchain, flasher, IDE, everything is open source. So it's very easy to develop. So yeah, enjoy. For $4, what else you need to spend your weekends? So there are many STC based chips which are all easy or equally easily programmable like this one. So yeah, you can get a couple of things. You can teach your kids to solder, and then and also you can teach them some embedded development very easily you can teach them. And then for any production grade applications, you can take a look at this firmware library, which is very capable. And this is totally exclusive for the STCC development using STCC. You don't need any Keel compiler or IAR commercial compiler. It's totally for STCC. So what else we need? Excellent. So I think that's it, guys. Yeah, take a look at it. Start with the code that I have put in GitHub. Start developing your own. Add more effects. You can even Thus for this one it has got a lot of purse space, meaning development space. You can add some either buttons and use multiplex between input and output and change the effect based on button press. You can try all those things, and there is also maybe add some sensor here, read the sensor and change the pattern based on it. Change the brightness using PWM, emulated PWM with a light sensor. So this has got a lot of ADCs. I think eight ADCs this have. So you can use one of them to read the value from a light sensor, LDR, or something. The possibilities are endless if you are creative enough. So yeah, there you go. $4.32 core development board for your pleasure. So that's it for this video, guys. Cheers. Ciao.